Hi Year 12. Firstly, disaster has struck and I don't have a purple pen, so I've had to work in blue and green and black. Real disaster zone around here. Secondly, if you can hear the baby crying, I do apologise. She is being looked after. I haven't just abandoned her, but it's close to bedtime here. I just wanted to make a video to talk you through a couple of things that have come up with the work you've been doing on hypothesis testing. What you've been doing is really, really good, but there's an alternative method, and in the exam board mark schemes, they're looking for this, and I'm not sure if they'd allow other methods. You'll see what I mean in a minute. It's just a certain way of writing it, and it deals with when you're trying to work out a value that gives a particular probability. So if you're trying to work out the critical region, for instance, there's a way of writing it down, which is the way they seem to prefer. Before I get onto a question like that, I'm just going to step back a bit. This is actually a chapter 6 question, but it leads nicely into what I mean. So if you look at the question we've got here, it's a spinner is designed so the probability it lands on red is 0.3. Part A is very straightforward. Find the probability that Jane obtains at least 5 reds. It's just your probability that it's 1 minus that she obtains at least 4 reds, which you just do on your calculator, which would give you that probability there. However, then we get into the more complicated bit. So Jane decides to use this spinner for a class competition. She wants the probability of winning to be less than 0.05. So we want to know how many times out of the 12 should you, how many reds out of 12 does she want that the chance of getting that many reds is less than 0.05. So what we're actually working out is we're saying how many reds do we need so that the probability of getting that number or more is 0.05. So are we saying that if we got 10 or 11 or 12 reds, would the probability of getting that number of reds be less than 0.05? What if it was 9? What if it was 8? We're trying to find what number of reds we need to get a probability. When we work out that probability or greater, the probability is less than 0.05. Now, if you look at the probability x is greater than or equal to r, we know, and what you're all very good at writing now, is that's the same as the probability that x is less than or equal to r minus 1. Remember, if we wanted to work out bigger than 5, we did 1 minus less than 4. Okay. Then what I'm doing is I'm just going to rearrange that equation a little bit, okay, so that we end up with 0.95, so all the numbers on one side, and x is less than or equal to r minus 1 on the other. Okay. And rewrite it the other way just because that's how we're used to seeing it. There's my mistake, did my inequality sign the wrong way. So we want to know what value gives us a probability more than 0.95. Now this method of writing it with the r minus 1 and all of that is how the exam board are writing it in the mark scheme. So that is the way that's going to be best to show your method. Then what you do is you just try out values. Okay, so you can use your binomial distribution. So if you tried x is less than or equal to 5, you'd get that probability. If you tried less than or equal to 6, you'd get that probability. Now we wanted one which was greater than 0.95. So the first value that is greater than 0.95 is your 6. The answer is not 6 because remember we changed it from r to r minus 1. So 6 is your r minus 1. So your final value has to be 7. So this way of setting it out with your greater than r, then your less than r minus 1, and you're moving things around is the way that the exam board mark schemes are showing it. You may get the marks if you do it another way, but this is just the way that they are showing as a preference. Okay. If we look therefore at one more question, which is very similar, but is looking at your hypothesis testing now. So it is claimed 20% of women can distinguish between a cup of tea they have made and one their partner has made for them. Some people think that percentage is too low. So your hypothesis is going to be H0 is obviously going to be that 20% of women can distinguish, and H1 is going to be that more than 20% can distinguish, because the question says some people feel this percentage is too low. So we're working at the 5% significance level. We've got a sample size of 20, so I've set up my binomial distribution. Work out the critical region. So again, it's a question you've already done, but it's just looking at how we write it down. Okay, same as we did in the last question there. So we want to know what value, okay, so what value of r would give us a probability that's less than 5%, 0.05. Okay, so what number of people would mean that we then reject the null hypothesis? Okay, we're going to change that greater than or equal to r to less than or equal to r minus 1 minus it. And again, we're going to do our rearrange thing. which ends up with that. It always ends up with that, so you can just memorise that step if you want. So then we go into our probabilities, we try different values of R to work out what gives us a probability that's greater than 0.95. So if I tried less than or equal to 6, less than or equal to 7, 7 is the first value that's bigger than 0.95. So remember that's equal to your R minus 1, so R equals 8. That means that your critical region is X is less than or greater than or equal to 8. Sorry, because we're going back to the original question up here. Okay, so that's how we work it out. What I have done is got 2 questions for you, which I'm going to put in Classroom for you to have a go at. I'd like you to have a go at these before you do anything else today, and then send them to me or come back to me if you've got any problems. If you can use this method of your greater than or equal to R and then 1 minus it, rearranging it, that is definitely going to get you the marks, and the examiners will be super impressed. So it's a good way to write it down, and hopefully it's fairly clear too. Hope that makes sense. Come back to me. If not, send purple pens. Life is getting desperate, and look forward to seeing you all soon.